What is up, guys? Fahir here from AwesomeTuts.com, and I have a huge announcement for you. In my most popular course, you will learn how to create RPG and first-person shooter multiplayer games, and you can get that course at a huge discount. And this is not the best part. The best part is that I have created a special coupon code, and when you use it to enroll in the course, you will automatically be enrolled in my giveaway competition, and you will get a chance to win some cool prizes. What are those prizes? Well, first place is gonna get a 15-inch MacBook Pro. Second place is gonna get an iMac 27-inch with Retina 5K display. And third place is gonna get a 13-inch MacBook Pro. All you have to do to enroll in this competition is enroll in the course, and link to it is in the description below. You will also find another link to the video where I explain about the giveaway competition in more depth. In short, I will record myself drawing the winners and sending them their prizes depending on which places they are or they win, first, second, or third. So we'll see me sending these MacBook Pros, and you will see me announcing the winners, and I will post that on my YouTube channel. So again, first prize will win a 15-inch MacBook Pro. Second prize is 27-inch iMac with 5K Retina display. And third place is 13-inch MacBook Pro. What is up, guys? Fahir here from AwesomeTuts.com, and finally let us get into some scripting, because I know all of you were like, okay man, enough about creating these menus and these elements, let me get into some code. So yeah, I hear and I feel you, my brother. So let's get into some coding. Inside of the project tab, I'm gonna right click and create a new folder, which I'm gonna call, well, you can assume scripts, duh. And here I'm gonna right click and create a new folder, and this is gonna be our BG scripts, because here we're gonna store the background scripts, or actually the ones that are gonna move these pipes or these obstacles or bounds, or however you want to call them. So here I'm gonna right click, create here BG mover, so BG mover like this, and we need to attach it on all of our side boundaries. So I'm gonna select all of them by, well, selecting one, holding shift, then selecting, well, all of these. And right here under add component, I am gonna filter for the BG mover and hit enter. And this is, well, the way to add this script to all 4 of our bounds. Now I'm gonna, well, double click the script and open it here in Mono Behavior, or actually Mono Develop. I'm gonna tag the class here at the bottom, hold enter just to give a little bit of space as always, which we are used for me to do. So we need a couple of variables as always when we start a script. The first one is gonna be a public float, which is gonna be the move speed. I'm gonna set it at 3 by default. Let's say 5 by default. This is the default value. I set it to be public, which means it will be visible here in the inspector panel. Bam, here it is. So we have the BG mover script. We have the move speed value right here. Default one is 5, as we just saw. We also need to get a reference to private game objects. And this is going to be an array, and these are going to be our side bounds, not sounds, but side bounds. What is this? Well, we're going to get all 4 of these boundaries from the scene because, well, we need to calculate where we need to reposition each bound. So we will see that in a second. We also need a private float. So float is going to be our camera Y. This is the Y position of the camera. We also need a private float, and this is going to be our bound height. This is the height of our bounds. And this is all what we need for now. Inside of the awake function, so I'm gonna change start to awake, and I always get this question: why did you change awake or start to awake? Why are you using awake and not start? You can use either awake or start, but I talk about this all the time, and all the time I get questions about this. So we have awake, we have void start like this, and we have void on enable. All three of these functions are used for initialization. Now the difference is in the order of execution. The first function that's going to be called when you start the game is awake function. The next one will be onEnable, and the third one will be start. Now usually you are going to use awake and start, and awake is called before start. That's why I like to use awake. It's my own preference. You can use start as well, and it will work the same way. So inside of the awake, we need to get the reference to all of these bounds, but we need to get them using their tag. And in order to do that, we need to go back here in the scene editor or Unity editor. When you select any of these game objects, you will see here in the inspector panel below the name of the game object, you have these tags. It's a drop-down list. So you can click on the drop-down list and you can go here, add tag. So click on that, and then here you can create your own custom tag by clicking on this plus button right here. So if I click on the custom plus button, I can create my own tag, which I'm gonna call side bounds, like this, or side bound, however you want it. And I'm gonna click save. So it's side bound. They are put together. This is one word, no space between side and bound. This is important because now we need to tag, so select all of these side boundaries, and from the tag now you can select that side bound that we have created as our own custom tag. So here it is. When you select it, notice now every single one of our side boundaries will have that side bound tag. So all four of them. Now, why did I say this is important? So it's important because now we can go here in our awake and we can say side bounds is equal to game object, find game objects. So here we have plural, not singular. So S, it's objects with S. We can remove that and we can only find one game object with the tag. But since we need an array, meaning all game objects in the scene which carry the tag that we specify right here. So the tag is side bound. Now what is important here? This side bound, this tag name right here needs to be exactly as the name right here. So we see it's side bound, no space between side and bound. If we do something like this here, type space between them, we will not find those game objects and we will have a problem. So it needs to be the same. Same signature, same capitalization, everything needs to be the same. We also are going to get the camera Y. So camera Y is going to be equal to camera.main.transform, actually that game object.transform.position.Y. So this is going to give us the Y position of the camera. And what we also need to calculate is the bound height, which we calculate by using the box collider. So we need to get the box collider. Now notice both box colliders have the same size on the y-axis, so it does not matter which box collider we get. So simply here we need to type get component box collider 2D, and we need to say bounds dot size dot y. This is gonna give us the height. So how high, how large. When I say how high, don't think about smoking weed or something like that. It's the height. So how high is the bound game object? This is important because, well, we need to recalculate its position. Before we do that, so before we recalculate the position, we are gonna move it. So we're gonna say here void move. This is a function that we have just created, which we are gonna call in the update right here to move our game object, so our bounds. And we're gonna do it simply by using vector3 temporary variable is equal to transform.position, so the current position of the game object. Temp.y is gonna be minus equal to move speed multiplied by time dot delta time. And below, we simply need to say transform position is equal to temp. What are we doing here? Because some students do not understand this. If I take my highlight tool, we have created a temporary variable. So this is a variable temp to temporarily store the value. So to store the current value of our own position. So POS. So our current position is stored in the temporary variable. So now we are using the y value of the temporary variable, subtracting from it the move speed. So move speed like this, multiplied with the time delta time. Now time delta time is a very small number between each frame. So if we have 60 frames in a second, that is a very, very small number, and it's used in calculations like this. And simply then we use our current position, so POS, and we assign it the new position, which is our temp. That's the new position. So simply reassigning it back. So currently here we are storing it. So this is our current position. We have edited our current position and we reassign it back so that we have a new value of the position. So think of it like this. I have $10 and I give you that $10. So I give it to you and I tell you, okay, these are my $10. Store them for me. So temporary, hold them for me. But also go and buy me some gums, and that gum costs $1, for example. So $1 is the gum. So now from 10 you have 9. So that means you have 9 now. You bought me the gum and I tell you, okay, give me back my money. So now you give me back the current value or the edited value, which is now 9 and not 10 anymore. So it's not 10, now it's 9. So we are done with the movement. So here we have, well, calculated the new position. We are calling that in the update function. We can go back here and we can, well, simply hit that play button to see that they are actually moving down. You see, they are moving down and eventually they will run out and bam, this is the trouble that we have, or the problem, well, that we have. Now, it's not that bad idea since we have these box colliders on these game objects. We can select all of these and we can add a rigid body 2D, because if I just move it up, let me just move the component up. And why did I add a rigid body to all of these game objects? Well, the reason for it is because we have box colliders on them, and when you want to move game objects with colliders, it is a good idea to add a rigid body on them. But before I proceed, I will show you one problem that we have. So our game objects are simply going to fall down. You see, they just fell down. Now you might think this is okay because we have the script, but if I deactivate the script that is moving them, even if I remove it, they are gonna fall down. You see, they're falling down. The reason for it is because the rigid body is applying gravity to our game objects. So what we need to do is we need to go here and set them to be kinematic. So here from the drop-down list, body type is not dynamic anymore, it's kinematic. So I'm gonna put them here as kinematic, and if I hit the play button, so now they are going down, but because of the script. If I deactivate the script, so BG Mover is deactivated, they are not moving down. As you can see, they are not affected by gravity anymore. So they are not affected by gravity. If I change that to dynamic, bam, they are falling down. And this is what I mean. So let me turn back the script on again and put the body to kinematic, all 4 of these bodies. So it's a good idea when you have a collider on a game object and you're moving it, that you actually put a rigid body on it. If you don't want gravity, then simply put it to be kinematic, but leave the rigid body on that game object. So what is the problem that we have now? Well, the problem is that we are moving these backgrounds and eventually they are gonna, well, go away and we are not gonna have them anymore. So bam, as you can see right here. Now also one thing that we are gonna do in regards to our side bounds is that we are gonna take these trees and let me just take them, position -2, because I want these trees to be in front of our, well, obstacles here or side bounds. You see, the trees are now in front. If I put them back at Z, so Z position is at -2. If I put it back at 0, you see in the front line, we see, I'm not sure if you're actually seeing this. I'm going to zoom it back. So here, notice all of the trees are behind these bounds. If I put the front trees at -2 for the Z, they are now in front of the boundaries because I want to create that depth effect. So now moving back to our script, what we need to do is we need to reposition them. So here I'm going to say void reposition, And we need to call this function right below the move function. So right below it here, call reposition. Inside of the reposition, we are going to test if our bounds are below the camera's Y position. So here we're going to test if the transform position, which is the current position of our bounds, dot Y is actually less than the camera Y. And for the camera Y, we also are going to do the following here. So we got the camera Y. I'm also going to subtract 15. So I'm going to say here minus 15, just so that I can give a little bit of space before we actually reposition the background. So if our current position Y is less than the camera's Y position, of course, we have subtracted 15 from it right here. So if our position is less, we need to reposition our background. How are we going to do that? Well, we need to calculate the highest Y of the backgrounds. Why the highest? Well, notice here. In the scene, you see the first bounds, this one that are here, you see I'm deactivating them. These first are at position 0 for the Y. The next one are at 10. The third one are at 20 and the fourth one are at 30. So what we need to do, when this side bound right here, so when it goes like this and goes below the camera somewhere around here, we need to reposition it back in front right here so that it can again go down like this and then be positioned back and again. So this effect is what we are gonna achieve. So let me position this at 0, 0 for X and Y to put it back where it was. And in order to do that, we're gonna say here float highest bounds Y. So this is the highest bounds Y is gonna be equal to side bounds element that's at index 0 dot transform dot position dot Y. How can I be sure that the first element in this array is the one that has the highest Y position? Well, I'm not, because when we use this game objects or game object, find game objects with the tag, it's gonna get all of these game objects that have this tag and put it in this array. Now, the order by which this function gets these game objects is always different. It does not get them like this, so side bounds will be element 0, side boundaries 1 will be element 1, side boundaries 2 will be element 2. No, it can be that side boundaries 2 is element 0 or at element 0, index 0 that is. Side boundaries 3 can be at element or index 1. Side boundaries can be at index 2 and side boundaries 1 can be at index 3. Now my point is that it will not get them in this order so that the last or first element will always be the one with the highest Y position. Instead, we need to compare the values. So here we're going to say if, or actually we are going to say for int I, which is equal to 1. Why 1? Well, because here we used 0, 0 index. We don't need to test element that's at index 0. Instead, we're going to test other elements. So for Y or int I that's equal to 1, I is less than side bounds dot length I plus plus. So we are going to filter through the array and we're going to test if the highest bounds Y, which we assigned to be equal to, well, this right here, if it's less than side bounds element that's at index Y dot transform dot position dot Y, that means that this element here at index I in the array has the higher value for the Y-axis, which means that we're going to say our highest bounds Y is equal to this right here, like this. So what we are doing here, let me just go here and, well, demonstrate this with a highlight tool. Let's imagine that element at index 0 has a value of, let's say, 5 for Y. So his Y is equal to 5. We assign that to the highest bounds. Now, that does not guarantee that this right here, or the element that's at index 0, actually has the highest value for his Y-axis. That's the reason why we are testing. So we are looping through the array here and testing if the current value of our highest bounds Y is less than Y-axis or Y value from the element that's at index y. If that is true, so let's say this I currently has value 1. That's element at index 1. And that element at index 1 has a y value of 7. So the y value here is 7, which means this value here, the first one, is actually less than 7. So we are testing if it's less, and that is true. That means we need to reassign this 7 to this value because it is the higher value. So this is what we are doing here. So now that we have the highest y value for our bounds, what we need to do is simply we need to say here vector3 temporary position is equal to the transform that position, and we need to say the y value of our current bound is going to be equal to highest bounds, so highest bounds y plus the bound height, and that is that. And here we simply need to say transform dot position is equal to 10. Why the bound height? Well, if I go here, let's say the highest value is 30, and we want to reposition this one, so we want to reposition this one here. Now, if I say that the highest y value is 30, and I want to position it above the one, and if I put it here at 30, notice it's at the same spot. So it's exactly here. You see, we have this one, it's right below it. Let me just go here. Come on, reposition back. So it's at 30. So it's at the same, you see, they are at the same position here. We don't want it. We want this one to be above that one right here. And we know that all 4 of these bounds have the same height. So we can use that. So we can say, okay, I want this to be at position 30, but also I want to add to it its height, and its height is equal to 10. So that means plus 10, that means it's 40, which means bam, it will position it, you see, it will position it above the down one, so the previous one. Actually, it will reposition it back. So we have it right here. So we have calculated, we are calling this, let me just save the script. It's really important. What did I do here? Okay, so I just duplicated this code, so sorry for that. Anyways, it's really important that you save your scripts every time you type some code out. Command S or Control S on Windows to save the changes in your script. So we are calling these functions here, and let's see that magic happen. So if I go here, hit the play button in the scene, notice now when this one, you see, it's repositioning it back. Did you see that? It is repositioning back these backgrounds. And notice here how we have that in our game. So this is how we have it in our game. You see that little gap that we had? Yeah, we have this gap right here. So we can fix that gap by doing something like this. So we can say bound height, let's say -1. Just to, well, subtract 1 from our bound height so that we can actually fill out that gap. So if I go back here, let's see if we have that gap again between these. No. So yeah, this is the effect that we want. We don't have the gap between our bounds that we had, well, a moment ago, just by subtracting 1 to fill out that gap. And notice, they are repositioning this whole time. It's calculating where is the highest y value all the time. And it is putting these back up and up and up and up. So we have this infinite background effect. And if you take a look at here, you have an assumption, so you have a feeling like the camera is moving, but actually no, the bounds are moving down, and you think the camera is moving upwards. So this is some new features that we have learned so far, because most of the time in Infinite Runner games that I did, or tutorials that I did for Infinite Runner effect games, I moved the camera, but now I'm moving the game objects themselves. So you see what I was talking about. You see this one? It's going to be repositioned on the top. Bam! It's on the top. And again, they are stacking upon one another. So this is what we are doing here. Calculating the highest y and repositioning it back using the highest y plus the bound height -1 to fill out that gap. Fahir here from AwesomeTuts.com. Catch you guys in the next video. Before we end this video, don't forget that you can enroll in my most popular course, Create Your First RPG and First-Person Shooter Multiplayer Game in Unity. Link is in the description below. And when you enroll in the course, you will also enroll in my giveaway competition and get a chance to win one of my cool prizes. First place will win a 15-inch MacBook Pro. Second place will win iMac 27-inch with 5K Retina display. And third place will win a MacBook Pro 13-inch laptop. Now, all you have to do to enroll in the giveaway and get a chance to win one of these cool computers is enroll in the course. Again, link is in the description below.